Hi, everyone. Thanks for joining today. As you know, I'm Naomi Caduella, head of Kavi Labs, and Kavi Labs is the solution, innovation, and incubation arm of Kavi Global. We have been partnering with many universities for the past few years in an effort to do exciting new R&D on the technology space, data and analytics space, RPA space, IPA space, the robotic process automation and intelligent process automation, intelligent apps with embedded AI, all new R&D so that we can make sure that we're on the cutting edge of products that we can make available for our clients. So UIC, we've had a long partnership with them. This is, I think, our third batch of capstones, and each time we just keep getting better and more innovative and more exciting work coming out. So I'm really excited to present you guys the AI trading bot capstone team, an intelligent process automation solution. So without further ado, let me turn it over to the students, and you're going to hear some exciting modeling. There's forecasting, there's even reinforcement learning. So I know we don't see a lot of reinforcement learning on the industry side. It's still very much in R&D and looking for applications, but we have found a suitable application, and you're going to see the approach and some of the results today of this initial AI crypto trading bot. So thank you all very much. And without further ado, students, I will turn it over to you to kick off, introduce yourselves, and dive in.
All right, yeah, good morning and good evening to those of you abroad. My name is Chris Corwell-Gressler. I think we're all in this group, MSBA students at UIC. I did my bachelor's in finance also at UIC, and I've worked at UBS prior to joining the MSBA program. I'm very interested in AI and the applications of machine learning, or machine learning that looks more like artificial intelligence, and very happy to work on this project.
Hello everyone, my name is Anisha. I'm a graduate student at UIC, and prior to this I had 6 years of experience, and also done my MBA in engineering, and my last working was with Bank of America back in India. And I really love how technology and finance can work in together, and we can really enhance the processes with the power of data analysis and now data science as well. So it's very exciting for me, and working with Kavi was really exciting. Thanks.
Hello everyone, Bhanshu this side. I have, prior to joining the MSBA program at UIC, I worked for 5 years at Excel Insurance as data analyst, and here I'm here to learn more about machine learning, AI, and its implementation. And this capstone project at Kavi was really helpful to learn everything, and I really hope next 1 hour would also be helpful and worth your time. So thank you.
Hi, I am Prachi, and I'm a graduate student at UIC, majoring in business analytics. Previously, I have worked in the financial sector with HDFC Bank in India, and my current interests are project management and visualization. This project has been very useful for me to understand how teams work in an agile environment, as well as combining the business solutions in terms of visuals and getting a hang of Power BI. Thank you. So today's agenda would be starting with business problem and architecture, and then we will look at what data we have used and what models. And then Chris would be talking about how we selected our cryptocurrencies and how we used reinforcement learning. And then Vibhanshu would be speaking about how we have visualized our results in Power BI, and then we will discuss the recommendations and what can be the future scope of this project.
And I think at the end also Q&A.
Yes, and the Q&A. So our business problem was to develop an algorithmically driven crypto trading system. This system will look to make trades on behalf of users as a part of the new product that Kavi Global wants to offer. So our project, as Naomi said, is all around RPA and the IPS. Currently, the global fintech market is anticipated to grow at a CAGR of around 20% over the next 4 years. And Kavi wanted to break into the fintech space. through high frequency crypto trading because of high volumes of data from live market feeds and the frequency of trades at the granularity of milliseconds, which is not manually possible. So IPA was the solution for this high frequency trading, and IPA has been commonly used by many investment banks, hedge funds, and institutional investors. So millions of orders can be executed and scanned at the level of milliseconds through IPA. Beyond the speed and the strategic viability of our system, we needed to have machine learning AI built so that we could stay competitive over time, evolving with the ever-changing market. We did not want a rule-based engine that would require recoding every time, so we have used reinforcement learning in our model. The reinforcement learning model is very unique to our project, and nobody in the industry is currently using this for high-frequency trading. Now let's have a look at our solution architecture. In the data ingestion phase, our model is getting data which is historical as well as which is current or the live data. This data is then being fed into the forecasting models to make these predictions. And these predictions are further fed into the reinforcement learning model. The reinforcement learning model makes predictions and decides an investment strategy, whether to buy, sell, or hold. And this result is then visualized in the form of a Power BI dashboard in terms of portfolio movement as well as the movement of the cryptocurrencies. So for cryptocurrency markets, sentiment analysis is also a very important parameter because the market movements in crypto trading are highly influenced by what is happening on Twitter or what is Elon Musk is saying or what is Mark Zuckerberg saying. But currently this was given the time limit, it was a little difficult to implement in that time frame. So we have used it as a part of future scope. Next slide. So we got the historical data of 20 different cryptocurrencies from the Binance API at the granularity of 1 minute. And we also connected our models to the live market feeds from the Binance API. We then used feature engineering to get some calculated fields regarding the technical indicators of cryptocurrencies, usually volume, trend, momentum, and volatility, and incorporated those in our models. And we used modern portfolio theory to pick 5 cryptocurrencies that our model will work on. We train our model using the historical data, and our predictions are on the live data that the model is getting from the market. And whatever are the results, they are being visualized in the Power BI dashboard in terms of live portfolio movement. Thank you.
So next we have the solution architecture, and as Prachi had highlighted that we had a data stream of Binance API, and our market data was in OHLCV format. From that, we got our derived variables, which were the training indicators, the ratios that indicate how the market movements are happening in terms of momentum, velocity, etc. And then from this, we did a forecasting of the feature vector, and there was a forecasting model, and for forecasting we had used Profit, but the other options like ArimaVar or LSTM can also be used in future, and we can see the difference in results. And then finally, from the forecasting model, we had the trading feature vector, and from there we had our portfolio control model, which would actually lead to deciding whether the agent should buy, sell, or hold. And accordingly, the trade can be made with the broker. And once the portfolio position is finalized, then we have analyzed everything using a Power BI dashboard. So currently our Power BI dashboard shows that at the start we invested 25,000 and how that 25,000 has progressed over a period of time. So our data overview looks like having a start timestamp, open, high, low, close volume, end timestamps, and the volumes and number of trades. and the base asset volume. So over here, I want to highlight why did we choose Binance API? Because Binance API was the only API which was allowing us 1 minute transactions, and it was available freely to us. And as a prototype solution, we wanted to invest in that as a part of a solution. And we used OHLCV data for 20 cryptocurrencies at the granularity of 1 minute, and the feature engineering itself was done on this OHLCV data. So some of the financial indicators under volume, volatility, trend, and momentum helped us see how all the cryptocurrencies are moving in terms of time. And even though we had these graphs in place, but still somewhere it became difficult to select exactly which cryptocurrency should we select for our final model from 20. So that's where we used MPT theory. And in later slides, we will be talking more about that. So the first question is why a two-bot model? Because over here, in order to trade autonomously, there were two problems which we need to solve. The first one was to predict how and where the asset price is moving, how the asset price of these 5 cryptocurrencies are moving. And once a prediction is made, then we know whether or not a trade should be made. So rather than going for a rule-based algorithm, we opted for a reinforcement learning model, which is a very important part of our project. And it helped us in being more confident about the result rather than relying on a rule-based algorithm in such a dynamically changing market. So these models have been rigorously tested on historical data, and we know that as we proceed ahead in time and the model keeps running, there might be some changes, but still we won't be able to capture black swan events like a Ukraine war or a COVID, and that's normal. So yeah, so we had Profit for forecasting. We had also tried Arima, but somewhere with the Azure Databricks environment, it was not working. So to give an introduction about Profit, it has an input data frame in terms of the timestamp DS and the Y value which we need to predict, and as an output it gives us the predicted value and also the confidence intervals in terms of high and low of how that is being predicted. So over here we just focused on getting 20 minutes data along with the confidence interval. And our actor to critic model was the part of reinforcement learning, and it has an agent which can figure out whether it has to buy, sell, or hold, and accordingly a decision can be made so that we have an optimized control system which offers us a risk averse model as well. So next slide.
Thank you. Thank you, Nisha. So yeah, so those were our kind of modeling approaches to the solution. But to actually make money in the markets, not only do you need a robust solution that can trade and forecast effectively, you also want to be exposed to assets that are conducive to being profitable. You don't have infinite money, so you can't invest in every single asset. And even if you could, the interactions between assets may end up canceling out some returns. So to determine which assets we think are useful being exposed to, we looked into the financial literature. From my time at UBS previously, Markowitz portfolio theory is, you could say, the industry standard or something that's basically used everywhere. It was developed in the 60s and it's still used to this day. However, MPT and Markowitz's theory is really only a mechanism for determining the optimal allocations for a given set of assets. So assets an investor already wants to be exposed to. It only tells you, given some historical data, which of those assets or how much you should be exposed to each of those assets. One of the novel things that we did in this project that was quite time consuming was figuring out how to repurpose MPT as an algorithm that could be used to effectively do forward selection on these assets. So determining out of a set of assets that fit some conditions. For our intents and purposes, these were high volume and high volatility, and also having what you might consider a stable base, avoiding the meme coins like Dogecoins or items that are purely fueled by hype, although there may be profit opportunity there. For this part of the project, we excluded those from the set of things that we were interested in looking at. And basically wrote our custom algorithm, ran forward selection, and we got these 5 tokens down at the bottom. If you look at the right, you can kind of see one of the plots of what Markowitz portfolio theory kind of does. And at a high level, what the theory shows you, and then what our algorithm then subsequently proves, is that if you have a certain set of assets, you can have different allocations within those, and then those different combinations will result in different returns for those combined set of assets, and then an associated confidence interval, standard deviation, level of volatility with those returns. The numbers might be a bit small, but the best performing asset, that is the asset that provides the best return in this one simulation, or this one portfolio simulation, provides a return of about 1,250% with a window of volatility at about 1,200%. So in the one standard deviation, worst case scenario, you walk away with 50% of your portfolio gain, so 50% above. And then in the best case scenario, you walk away with 1,200x. So that's very, very, you could say, it's a very optimistic view or very interesting view. But then what's also interesting is the tail end of this distribution, where all of the assets that are very, very stable, or portfolios that are very, very stable, don't have a very high associated level of volatility. All of these are performing negative 250%. I don't know how you could lose negative 250% of a portfolio, but if you had held these assets in full, this is what you would experience in terms of returns. So we ran MPT forward selection, very interesting. Q&A, we can talk more about it. Next slide, please. Awesome. So reinforcement learning, and why do we choose reinforcement learning as the control model? So you could try and do it with supervised learning. However, there are no labels. So in the market, whether or not you should make a trade is a speculative decision that isn't associated with, there isn't a yes or no, that was a good trade answer. There's only generally good behavior or bad behavior that an individual trader can exhibit. And typically that's parameterized by the amount of profit that trader is able to earn. Reinforcement learning differs from unsupervised learning and supervised learning in that there are no labels. And it focuses on this notion of optimizing a policy or optimizing an agent for a specific environment. And the real kind of important term to keep in mind is that reinforcement learning is about teaching an agent how to learn the best policy or set of rules that will give it the highest reward for controlling itself in that environment. So RL is typically used in many robotics applications, and there's some interesting work done with the game of AlphaGo, where an RL agent learned how to play a game with itself or against itself and then beat out the world champion. But for our intents and purposes, how we decided to look at this problem was, hey, determining whether or not you should make trades, being given a continuous vector of observations at every time step in the granularity of data that you're working with, being given a set of observations and then mapping that to a decision is fundamentally a control problem. It's observing the world and then deciding what to do given that information. So reinforcement learning, in our opinion, seems to really suit this problem. And although it is very, I guess you could say, sample ineffective, it requires a tremendous amount of data to learn a very viable policy. There are some mechanisms to kind of increase the amount of data that we actually have access to. And then there are also RL algorithms that are sample efficient. That led to kind of our A2C actor critic style architecture, which is known for being reasonably sample efficient given the set of all RL algorithms. So it's more dynamic. It's not necessarily as brittle as supervised learning in that it doesn't have the labels. And RL can also pick up on things that humans may not be able to pick up. It kind of avoids any biases a human might bring to the data set when they're thinking about how they might solve a specific problem. And it learns kind of from scratch what it should do to optimize to get the most amount of reward it possibly can in a given environment. There are 3 types of RL, or RL kind of falls under 3 different flavors. You have model, policy, and value-based reinforcement learning. Model-based learning really focuses on whether the agent is trying to predict the actual world. It's the changes that happen in the world. Policy-based RL focuses on the actions. So basically saying what action at each time step is going to be the best for my future performance. And then value-based RL is effectively looks at determining which states are the most advantageous states to be in. And a combination of policy and value-based RL is what A2C is. And we chose it for this problem because we believe that the agent doesn't necessarily need to model the markets in its entirety. It might be a bit of a moonshot idea. However, learning which best actions to take at each time step in your simulation or in your environment or in the real world when you're trading, and then learning which states are very valuable are both items that we believe would be robust to new data and to new trades. So reinforcement learning, in short, that's why we chose to use it. Next slide, please. And how we decided to model this RL agent is with this directed trading graph. So RL, you can have continuous to continuous, discrete to discrete. Effectively, you have an observation of the environment, and then you have some action you can take. For this iteration of this project, and definitely we're very, very early stage, we're just prototyping stuff at the moment. We decided to parameterize this as a 3-action discrete output scenario, where each action would be tied to some sort of API call or some sort of decision per each time step that the agent is operating in. So it is directed in that the agent can only go from one state to another state as per the lines on this diagram. The agent can hold in any situation that it's in. But the items in red, which are of interest, are the trading fees. So on Binance in particular, and really with any trading platform, there are tax fees. You have to pay the road tax in order to use their platform and their service. Understandable, of course. Typically, in most of the literature that we looked at, when people have tried to model trading algorithms and develop bots for this kind of purpose, they've ignored the transactional fees. And what that kind of leads to is even, I guess you could say, an order of magnitude more trades than what a scalper trader might do if you're familiar. Basically, that means that it makes an erroneously large number of trades and just kind of reaps the percent of a percent gains with this very, very large number of trades. If you force the agent to kind of pay a tax or actually endure the transactional fees that happen in the real world, what you do is you disincentivize making very, very, very frequent trades and incentivize making medium trades that might lead to gains in spite of the transactional fee. Transactional fees at 1% are very, very much of an overestimate. Typically, they're less than 0.5% or 50 basis points in the actual markets at most, and those do tear off as you increase par value of your portfolio or your portfolio holdings. But we decided that a more overestimate is better than underestimate, and you incentivize the trading behavior that would lead to better gains over time for the agent. And then the agent in this formulation is being rewarded for advantageous positions or trades. That is, if the market is going up and it buys and it holds, it's being rewarded for reaping that profit. We've thought about and explored the idea of incorporating the portfolio as part of the agent's reward function, but that's for future work in the next iteration of the project where they actually do some more optimization. Next slide, please. And then this is just kind of a brief thing that we wanted to touch on, but we had to basically write this entire reinforcement learning algorithm environment from scratch, in addition to the actual agent and its code. This was quite a challenge, and unfortunately, there isn't much literature on doing this, or that which exists is not very generalizable. So we really had to think about this from scratch. However, the upside of thinking from scratch, from first principles, and building it from the ground up is that what we developed for Kavi in the custom gym environment, which is how typically RL agents would interact with a given environment, is quite extensible and entirely custom to your guys' kind of solution. So that's a huge, huge plus for you guys. And what this environment offers is a standardized way to read tabular data and run a simulation for a reinforcement learning agent to learn from that simulation, that environment. It's extensible in that you can change up the features you include. So more work can be done on determining which of the trading indicators are most predictive or lead to the best types of policies learned. And you can also add new items. So if you wanted to add social media or any of the kind of economic indicators or macro indicators into the environment, those may not be necessarily useful for predicting the asset price of Bitcoin, say, but it might be very useful for determining whether or not you should make a trade if World War III is breaking out. Hopefully not. So if you were interested in including those things, they would be included in the environment for the agent to learn a policy given that information. And we provided kind of the mechanism for doing that. So that wraps up the environment. If you have questions, please do save them for the end. And then I think we're moving into prototype of our Power BI dashboard.
Awesome. So yeah, so again, I think Chris has already pointed out that these are the 5 currencies that we're working on. So that this is what consists of our portfolio: Bitcoin, Ethereum, Phantom, Atom, and Mana. So so the reinforcement learning model was trained using the historical data. That is the 1-year historical data Anisha was talking about, and it was at 1 minute frequency. So now our model is trained. Now it's time to get those learning and apply it to the live data. So now we are getting pretty much each minute data live from Binance Market and just feeding it to the Power BI. So it's stored in the Azure database and Azure data cluster, and that is imported to Power BI. And using the reinforcement learning, we are getting these signals for each currency. So you can see we have got data for these currencies. So the price for these currency at each minute, and these are the signals that the model is generating. So it can be hold, buy, sell, and so on. So this is the historical table. So this will capture all of the data. So whenever we start the modeling, it will keep on capturing data and go on. This table is present in the Power BI dashboard. And after that, we got this data, and there are some of the data manipulations that we did within Power BI using the DAX language. Okay, and we can move on to the next. Yes, so this is how the portfolio change would look like. So basically our investment strategy is for this model is we start with $25,000 cash. So that is the money in US dollars in our bank account that we want to invest. And basically every time there is a buy or sell signal, we make a transaction of $500 and we can invest in that particular currency or sell that particular currency for basically the shares, it can be any amount of share that we can buy in $500. So for Bitcoin, obviously it's like one of the biggest currencies. So $500 would fetch you like a fraction of currencies, whereas Mana and other small currency, you will get a bigger share. And this is basically the overall change that you can see. So this is the this is our basically the value of our portfolio at current time minus the what we originally invested. So at the right, it would be $25,000, and that will be subtracted from the current portfolio value. We can move on to the next. Yeah, so this is pretty much how it looks like. This is the face of our dashboard. So you can see the price of each currency at each timestamp. And on the right, you can see the $25,000 is the initial portfolio value. And yeah, this is not even the refined model. We are still improving the models, but we still made some profits. So it was so we ran it for a couple of hours, and it does make money. So like profit is real. So and basically within a couple of hours, this is a good amount of money. So yeah, this model is working, and we are again fine-tuning it. So yeah, I think that's pretty much it.
So when we talk of recommendations and further steps, obviously this was a great learning experience for all four of us. And like the biggest challenge was deciding how do we figure out a data source which can give us the data in this format, and what exactly do we do with that data. So the models about which we talked, the reinforcement learning model and the forecasting model, we took a lot of good amount of time to even arrive at a conclusion that okay, this is what our next step looks like. Because when the project was given to me, it was just an idea, but from that ideation phase to coming to this level where we can say that okay, if we invest money, then we can see how the trades are happening over a period of time. So despite all this, we still have a few recommendations and further steps. So the first step is diversifying the portfolio by adding more cryptocurrencies and more frequent data. Because the more data RL model the agent trains on itself, the better the accuracies will be over a period of time. And then we definitely need to do some sort of performance testing before plugging the model in Binance API. There is extensive performance testing which is required, because there might be lag variable, there will be job scheduling, there will be emergency stoppages, and also how do we decide on computational resources and what our next steps will be in that direction. So we also need to have more improved financial indicators. If we can decide these are the best indicators as per the given cryptocurrencies individually, like subsets of cryptocurrencies, and then we say that for this cryptocurrencies, these top 5 feature indicators are the best features holding the highest importance. That way we can fine tune the model even further. And as we have indicated, we need to include sentiment analysis, because the data from social media applications like Instagram or Twitter does does make changes in how the cryptocurrency market is working. And lastly, we need to fine tune our model for better performance. For forecasting model, instead of using profit, we can use LSTM, which has a proven track record of highest accuracy in terms of time series models. And for control models, we can go with PPO and ACKTR models, which will provide us a more optimized control function rather than having reinforcement learning with agent and its environment. So that's it from us, and we open the floor for questions.
Thank you guys so much. Any questions or just comments, guys? Don't be shy. Feel free to share any thoughts that are coming to mind.
I have one question about the time constraint for making decisions you mentioned. Is there a time constraint, like you have to make decisions sell or hold within seconds or within minutes or within days?
Yeah. Great question, and this is something that we recommended in our kind of future work. At the moment, the agent is operating on the scale or the order of minutes, so there is sufficient time if you're running it in an online fashion to get a prediction within the minute. If you move it up to seconds or milliseconds, then you start to get some computational. You have limits on how much you can do in that time. And although kind of getting inference out of an RL model takes a couple milliseconds, actually getting the observation from the API, all these things start to add up. So at the moment, computational, there isn't really an issue in terms of the time frame that we're working with. But to get it to the level of, or to move it up a couple of notches, it would take, there would be tremendous amount of re-engineering that would need to be done in order to kind of optimize it for that very, very quick inference, regardless of what happens kind of next.
Yeah. And in terms of technology, also, there are a couple of roadblocks. So you get the data from Binance and store it in the Azure database, then do the calculations there, store the results back, and then present it to the Power BI, which is refreshing on live basis. So obviously there are a lot of constraints, and if you actually move it to the development, it would require a high level of computational resources to perform these kind of calculation. And I think that should also be considered as an initial cost while we're doing it, so that we know exactly how much money we are making, because buying these resources can be very expensive.
Yeah, thank you very much for your responses. And so I have another question related to this. It's as you mentioned, considering the time constraint, sometimes we need more resources for computation. And I remember you mentioned around page 13, you use some combination of policy iteration and value iteration. So I'm considering how in a high level, intuitively, how you combine the two methods, especially for policy iteration. Generally, its computational complexity is a huge difficulty. So maybe I'm wondering, you did some approximation to get the value function. Also, so those are the things I'm not clear.
Yeah. So it is clipped. It's not a full. It would be infinite, effectively infinite, if you wanted to model the full kind of output or the full value function that's required. However, a lot of the kind of more modern RL algorithms do clip or do estimate from the probability distribution of kind of value states to be in. And that proves to be sufficient. It's sufficient for the game of Go. And that's a very, very, very complex problem. The way that it's kind of implemented as it currently stands, it's a dual output neural network with kind of an output head and or a policy and value head, actor credit heads, respectively. So yeah, those are both trained simultaneously, and they, in terms of the actual computation of getting kind of inference out from an observation in, it's not too burdensome at the moment. But then again, you're not taking the full scope of interactions that could occur at each time step. It's a probability distribution. It is a clipped variant.
Okay, thank you. And
this is Vijita. I have a couple of questions. The work you did, you mentioned a little bit about the commissions and that's impact. Are you taking commissions and other costs into the work you're doing right now? And the second one is the investment, 25,000. I think you said, right? Is it leveraged or it is not?
So yeah, at the moment that investment's not leveraged. It's just spot trading. And in the crypto markets, doing kind of options, getting into futures, those are a bit. It's in its infancy in that regard. However, for the trading, with regard to transaction fees and kind of the cost of the road, those are factored into the environment. I don't know, Vivanshu, if those are factored into the dashboard as well. I believe they might be. But yeah, as far as the agents being trained, from what we've done in terms of prototyping that process, those are factored in.
Okay, thank you. No, even without the options, I think when you open the account with the trading firm, right, they allow you certain
leverage,
leverage, and it's very high in the currencies, 10, 20.
The forex exchanges.
Yeah, so that if you're leveraged, that can explain how do you lose the 200% or even more. Because if you are leveraged, your capital can disappear in a jiffy, right?
In an instant, yeah. We'll pay out. Yeah, forget.
Hey, great presentation. Let me start off by congratulating the team. I had a question. So what's the remaining work? Let's say if we want to set up a account with Coinbase and probably start with a certain $1,000 and let the trading bot go. What do you think? What's the remaining work in getting that going?
Yeah, I would, if I had to estimate, I mean, you guys feel free to chime in. I would say at a minimum, a full semester of capstone work, more likely 2 or 3. Although we made tremendous headway towards like proving the concept. I do think that to do it right, you want to be resilient to black swan events. And you really want time to just kind of flesh out which models, which architectures is value important, is the policy important, what types of control models are useful, what types of forecasting models prove to lead to better policies learned. I think you really need a tremendous amount of time spent working through those items. And I think that's another 2 or 3 capstone semesters. So maybe 15, 45, 40, 45 by 40, 45 times 40 hours of work.
Okay.
So a fair bit of time, but I would say it is tractable. I don't think it's intractable.
Got it. Thank you.
Mm-hmm.
Any other parting questions or comments?
Yeah, I think because we still have time, my question is like, how helpful was the Azure environment on all this? Like, is the environment like so good? Do we have enough tools inside to kind of make this kind of perfectly work, or are we still lacking in the environment side of things?
As far as the environment is concerned, I think we do have all the resources. So we got the data, and we were mostly using PySpark to code. So there's a Python environment where you can code, and there are clusters to store the data. So as far as the width is concerned, I think for this project, it did have most of the technologies. For dashboard, we use Power BI, which is again a Microsoft tool only. So it's a bit quite streamlined, I think. We are yet to take a couple of steps. So we are yet to connect it, make a live connection to, let's say, Binance Market. So we'll have to figure out how those things are done and if Azure can be handled. I'm quite hopeful that it will. But yeah, so far, I don't think we faced a lot of concerns. There were a couple of concerns I think that Anisha might want to point out for the profit model. Other than that, I think it was streamlined.
Yeah, like I tried using Arima first, but somehow it didn't work on Azure. And then ultimately I had to figure out a way to do that. And Profit was one of the available solutions, and it had its architecture as well available. So when we were running all of the code in Python, it didn't work well. And it was like necessarily we had to use PySpark framework within Azure, and that's how the problem was solvable. So maybe one of the issues might be that as we move to a real, rather than having this current prototype, when we deploy the entire system, there might be some issues which we are not able to see at this point of time. And those mostly they will be technical computational issues.
Okay, yeah. Thanks, Chris. Yeah.
Oh, I just wanted to chime in, and Arun, when we deploy the solution, probably something like Azure Streaming Analytics or something might be required, right? You heard how the students mentioned bringing in data, doing processing, et cetera, and then kind of placing the trade. So to make it more faster and in real time, I think a future enhancement might be to implement the Azure Stream Analytics.
Okay, yeah, that should work. Maybe that should work. Maybe we can explore all those options. I think great job, guys. Yeah.
Any last questions, comments? If not, I think we can wrap it up. Thank you again, students, for an amazing capstone, deliverables, and this presentation. It's been a pleasure working with you all. So we wish you all the best in your future endeavors. Hope this learning helps make you competitive and you can leverage these learnings in all your future work. So thank you all and keep in touch.
Thank you all for your time today. And if you're waking up, have a cup of coffee. If you're going to bed, hopefully you sleep well.